We are continuing with Chapter 3 Logic. This is Section 3.5, Equivalent Statements and Variation of Conditional Statements. Objectives are: use a truth table to show the statements are equivalent, write the contrapositive for a conditional statement, and write the converse and inverse of a conditional statement. Equivalent compound statements are made up of the same simple statements and have the same corresponding truth values for all true-false combinations of these simple statements. If a compound statement is true, then its equivalent statement must also be true. The same goes if it's false. If a compound statement is false, its equivalent statement must also be false. As we go further into this section, you might want to recall the table on page 141 of your book that gives the definitions of symbolic logic. Okay, example 1, showing the statements are equivalent. We want to show that P or not Q, and if negative P, then negative Q are equivalent. So we're going to construct a truth table and see if the corresponding truth values are the same. We have P and Q, two different statements, so that tells us that we have 4 rows for our truth table. We write those down. And for the first compound statement, we're going to need the negation or not Q. So we're going to have that in the second column. And then we're going to look at P or not Q. So remember, if it's an or, then if either part is true, the statement is true. So we have true for everything except for both P and not Q are false. For the next one, we introduce not P, so we're going to have a column for not P. Remember with these conditional statements that it's false only if the antecedent is true and the consequent is false. That's the only instance. So looking at if not P, then not Q, we have not P is false and not Q is false. Okay, remember it's false only if the antecedent is true and the consequent is false, so this one would be true. For the second row, the antecedent is false, so it doesn't matter what the consequent is, it's going to be true. For the third row, the antecedent is true and the consequent is false. This is the instance where the statement would be false. And then for the fourth row, they're true. We see in comparing rows or columns 3 and 5 that they're equivalent because the truth values are the same. Next, we're going to look at variations of the conditional statement, where we have if P, then Q. So the truth value of a conditional statement does not change if the antecedent and the consequent are reversed, as in these symbols up here, and both are negated. So we have if P, then Q, and reversing them and negating them, we have if not Q, then not P. The statement if not Q, then not P is called the contrapositive of the conditional if P, then Q. We're going to write the equivalent contrapositive for if you live in Los Angeles, then you live in California. P is the first part, you live in Los Angeles. Q is you live in California. Okay, so it would be if P, then Q. Reversing these and negating them, we would have if not Q, then not P. If you do not live in California, then you do not live in Los Angeles. These are variations of the conditional statement. The conditional, these are difficult to read after a while. Symbolic form of the conditional would be if P then Q. English translation is if P then Q. The converse is if Q then P. The inverse is if not P then not Q, where both are negated but the same order. And the contrapositive is for the reversed and they're negated. So if not Q then not P. Conditional, the first row, and contrapositive are equivalent. Converse and inverse are equivalent. So we want to write the converse, inverse, and contrapositive of this conditional statement. If you are 17, then you are not eligible to vote, which is true. So P would be you are 17, and Q would be you are eligible to vote. So in symbols, we would have if P, then not Q. If you are 17, then you're not eligible to vote. Now we want to form the converse, the inverse, and the contrapositive. So for the first one, we're given if P, then not Q. The English translation is if you are 17, then you are not eligible to vote, and this is true. The converse is where we reverse the components. So if not Q, then P. If you are not eligible to vote, then you are 17. This is not necessarily true. For the inverse, you negate the components. So we would have if not P, then not Q, which simplifies to if not P, then Q. English translation, if you are not 17, then you are eligible to vote. This isn't necessarily true either, because you could be 16 and you would not be eligible to vote. And the contrapositive, reverse and negate the components. So it would be not Q, then not P, which the two nots simplified to Q. So if Q, then not P. If you are eligible to vote, then you are not 17. This would be true. And that concludes this section.